Ladies and gentlemen, I am John Pace, a member of the R.M. Santilli Foundation and the chairman of the World Lecture Series on Hadronic Mathematics, Mechanics, and Chemistry. It is a pleasure and honor for me to present Professor Ruggero Maria Santilli, who will deliver Lecture 3D on the invariant, classical, and operator gainomechanics, which is at the foundation of hadronic mechanics. Allow me to merely indicate that the achievement of this new mechanics has far-reaching implications in physics, chemistry, and engineering, since all processes of our environment are irreversible over time. Again, this is the second of a series of lectures delivered by Professor Santilli in the field. The subsequent lectures deal with chemical, experimental, and industrial aspects. Ladies and gentlemen, allow me to introduce Professor Santilli as a true scientific leader who has dedicated his life to seek basically new scientific knowledge in all quantitative fields, a leadership that is now followed by scientists the world over.
Ladies and gentlemen, thank you for your attention. Today I will deliver what appears to be the central lecture of this series. As you can see from the title, it deals with invariant, classical, and operator Lie-Admissible mechanics, also called gainomechanics or Lie-Admissible gainomechanics. The most important part of this title is the word invariant, because without an invariant representation of irreversible processes or system, I don't think there is any result worth reporting. By invariant, remember, we mean the prediction of the same number under the same conditions at different time, as well as additional conditions for invariance of the hermeticity, invariance over time of the numerical values of the unit of measurement, etc. Okay, I place this lecture at the center of this series for a reason, because it requires the prior knowledge of gainomimathematics, which was presented in lecture 2C. In turn, gainomimathematics requires the prior knowledge of isomathematics. Also, to appraise the Lie-Admissible mechanics, we need the subsequent lectures on experimental verification, application, and industrial development. So allow me to alert viewers who are not familiar with gaino and isomathematics, because there is a very natural tendency for misinterpretation. Let me illustrate this possibility as follows. Suppose that I come to you and say, I want to elaborate the Schrödinger representation of the hydrogen atom with gainomimathematics. I'm sure all of you will unanimously agree, Ruggero, this is total non-scientific nonsense. Now, Schrödinger equation for the hydrogen atom must be elaborated with the mathematics of quantum mechanics, Hilbert spaces, and so on. Well, ladies and gentlemen, we have exactly the same situation. That if any of you is not familiar with the appropriate mathematics, has therefore a very natural, in perfect good faith, tendency to appraise what I have about to say via the use of the mathematics of quantum mechanics, ladies and gentlemen, the outcome is exactly the same. Total non-scientific nonsense. So with this suggestion to exercise caution and learn all the preceding lectures that I cannot possibly present, let me initiate the lecture. I have divided it into three levels. Level 1 is an outline of the invariant classical Lie-Admissible mechanics. Level 2, an outline of the invariant operator Lie-Admissible mechanics. And I want to flash a few illustrations. And in particular, I would like to propose, if I have the time, a homework for colleagues that are interested. Again, each and every step is based on the prior knowledge of forward gainomimathematics. And I cannot possibly review in preceding presentations. Let's go back in time, 50 years or so, during my graduate studies at the University of Torino. Whereas you may remember from preceding lectures, I was fascinated by Lagrange's view of the universe because it was in dramatic disagreement with the 20th century perception of the same reality. And again, Lagrange was preoccupied with the external terms of his celebrated equation that represent indeed irreversibility. Notice the explicit time dependence. So I decided to dedicate my time to this legacy. Hamilton exactly the same legacy. Remember also, let's go back to 50 years or so, that I discovered with dismay that when you add the external terms to the analytic equation, then then we lose an algebra because of violation of right distributive and scalar law. So not only we lose the Lie algebra rotational symmetry, it makes spin 1/2 will make no sense at quantization because you have no rotational symmetry. That's nothing. You lose Lorentz. That's nothing. You lose all Lie algebra. And in fact, you use all not only all Lie algebra, you lose all algebra. As a result of this, I was totally paralyzed on how to handle quantitatively this legacy. And this was the beginning of a 50-year journey with all sorts of ups and downs, as you know. But we did achieve the preset goal because failure is not in our vocabulary, on the vocabulary of any member of any founders of hadronic mechanics. Let's go back now. These days we have achieved all intended goals. Let's review the conditions under which we want to reformulate this historical legacy. First of all, the desire is to reformulate it identically. You see the symbol here. We don't want to change the legacy. We don't want to change the equation. We don't want to change the forces. No. We want to reformulate it identically. In what way? In a way that verifies 5 conditions. First, you know, this dynamic evolution have to characterize a bracket, and let's call it AB bracket. And this bracket, first of all, has to characterize an algebra. If it does not verify the condition to define an algebra, ladies and gentlemen, I'm sorry, there's nothing I know what to do, how to treat them quantitatively. Then number 2, this algebra has to be a covering of Lie algebra. Here is a departure from mathematics. Mathematician can jump from a triple system and do other things, but we don't have that luxury. Because if the algebra that we have selected does not contain Lie algebra as a particular case, this means that the studies are now totally disjoint from Einstein and Galileo. I'm sorry, I cannot do that. Physics is a chain of events. Whatever I do has to recover identically and uniquely and unambiguously Einstein views under the condition not stated by Einstein followers. No, under the condition stated by Einstein. That's the proper way of honoring the name of Albert Einstein without abusing the name for personal interest. Then the next has to be, the description has to be invariant. We discussed this many times. If it is not invariant, let's not waste our time. The next one is that this dynamical equation has to be derivable from a first-order variational principle. If we don't have a first-order variational principle, I don't know, ladies and gentlemen, how to achieve an operator image of a classical formulation. I should mention in this respect that there are alternatives to external terms. For instance, by going higher in analytic equation. If you go third, fourth, and fifth order analytic equation, you don't need external terms because they are so rich. And there have been some fantastic research done in such a direction. I just want to mention my dear friend, Professor Miron from Romania, who has done fantastic work in those higher order equations. However, they do not admit a first order action principle. They admit a higher order action principle, and therefore I have difficulties due to the limitation of my knowledge. I do not know how to map it into an operator form, and that's the only reason why I stick to the original Lagrange and Hamilton's equation. Finally, condition number 1, perhaps the most crucial, first order action principle is not enough. You will see it in a moment. The action has to be additionally such to admit a unique and unambiguous operator map, or if you prefer, map into an operator formulation. You will see immediately the implication of the condition number 5. Please be careful, I beg you, do not use word quantization because it means this total non-scientific nonsense that we indicated before. because the word quantization will be anathema within the context of hadronic mechanics in its full irreversible formulation. At this point, I have to make a few comments on the following point. Colleagues from various parts of the world have asked me the following question. Dr. Santilli, you have spent a significant years of your time in writing a significant monograph on Birkhoffian mechanics, published by one of the best scientific publisher of the time, Springer Verlag in Heidelberg, Germany. And, and then you have done additional work on this mechanics. In particular, you proved that Birkhoffian mechanics achieves direct universality in Newtonian mechanics. Namely, I assume you know the meaning of our words. Direct universality means to represent all Newtonian systems, well behaved of course. That's universality. And directly in the coordinate of the experimenter. That's the direct universality, which is the foundation of everything we do in hadronic mechanics. For the very simple reason that we cannot put a 2 or 3 ton experimental detector on an hyperbolic orbit just because in this way I dream of recovering some preferred theory. No, ladies and gentlemen, this I leave it to others. The representation of system has to be in the frame of the experimenter, and that's direct universality. Birkhoffian mechanics verifies this crucial point. So the question is why, Professor Santilli, you have abandoned the use of both Birkhoffian mechanics and the Birkhoffian admissible mechanics for the development of hadronic mechanics. I think it's a point worth investigating, because it also illustrates the ups and downs of this incredible journey for so many years. And okay, let's review the transparency from lecture 2A. Regarding the classical counterpart, we are talking about 1978, the classical counterpart of the first achievement of the Lie-admissible covering of Heisenberg equations. The idea was, let me recall it briefly, the idea was that since the Birkhoffian mechanics is Lie, is the most general possible form realization of Lie in classical mechanics, since Birkhoff is Lie, then if I reach the classical equations, they are Birkhoff admissible, I'm sure that they are also Lie admissible. The solution was elementary. After working many years, several years at my preceding state visit at MIT, I knew very well Birkhoffian mechanics. I created the name Birkhoffian mechanics. And so forth. This was the equation. The tensor here was such that it is in contravariant form, but in the covariant form is such that its attached antisymmetric tensor is Birkhoff. Under this simple condition, very simply realized, this is certainly Lie admissible. You don't even have to waste your time to check it out. And this is the characteristics. Remember that totally symmetric part is not Lie. It's the Lie isotopic. It's the most general possible bracket verifying Lie algebra, and in the totally symmetric bracket instead are not Jordan admissible for reason we do not know. Those were the Birkhoff admissible equation. Ladies and gentlemen, after spending years and years in trying to build hadronic mechanics out of this equation, assuming those equations are as the classical counterpart, after years and years, I reach a point and say, I cannot, that's it, I have to look for alternatives. Why? This is the point I would like to elaborate. Both Birkhoffian and Birkhoffian admissible mechanics, they verify 4 out of 5 of the preceding condition. Look at this, yes, 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 and yes. The no is here. What is the problem? The problem is also what is number 4. Birkhoffian mechanics is indeed derivable from a beautiful first order variational principle. First order, so achieves you direct universality in Newtonian mechanics via first order variational principle. It allows you to subject the wing of a plane in air to the optimal control theory. The implications are far from being trivial. But what's the problem with the 5th condition? Well, because since you are in the most general possible framework in verifying Lie algebra, then the action principle is the most general possible first order. What does this mean? It means that, well, this is unified in unified variable A, which are R and P. But if you write this thing, this is the Birkhoffian action. If you write it explicitly, this is the expression that you see. What is the point here? The point is that this action depends on both the differential of the coordinates and the differential of the momentum. So because of this dual dependence, when you do the map into operator form, you end up with a wave function that depends on both coordinates and momentum. I repeat, both Birkhoffian and the Birkhoffian admissible mechanics admit indeed a beautiful variational principle, admit indeed a map into an operator form. Yes, however, the emerging wave function is very unusual because it depends on both R and P, it depends on both phase space coordinates. You just see it at the unified from here. You can see it from this unified form. The basic variable is A. The wave function will depend on A. A is R and P. Ladies and gentlemen, my knowledge was insufficient for me to handle at the operator level wave function depending on both R and P. And that's why I had to stop using Birkhoffian mechanics and search for alternative that will verify all this, but the first order principle should not depend on the differential of the momentum. This was achieved and achieved in full with direct universality. And because of the achievement of direct universality, leading to an ordinary wave function, then there was no need for me to build this broader mechanics. So after having said this negative aspect, things in science are never so very black and white. No. The Birkhoffian and Birkhoffian admissible mechanics one day may well be trigger a covering of hadronic mechanics. Human knowledge will never stop. The idea that we have reached the end of knowledge for the rest of time, this is politics, ladies and gentlemen. Every theory that we do has its own limitations. Indeed, it is not inconceivable that when future generations, when they look seriously at the interior of quasar and black holes, they may look at the sole dependence from the coordinates being very naive, limited, and so therefore they may be forced to enlarge the notion of a wave function with this type of dependence. In this case, Birkhoffian mechanics and Birkhoffian admissible mechanics will be indeed received the correct place in history. When this will happen, who knows? Next centuries or tomorrow morning, we do not know. So I want to close this point by stimulating the imagination of colleagues, because this is fascinating enlargement of both quantum and hadronic mechanics. Incidentally, the hadronic mechanics has been constructed as to be a covering of quantum mechanics. So I could not escape from the sole dependence from the R coordinate. Okay, this was another constraint. I could not work with this structure. So if somebody succeeds in constructing a consistent operator theory admitting Birkhoffian mechanics as the classical counterpart, automatically they have to enlarge quantum mechanics to this type of dependence. Otherwise, their work will not resist the test of time and will be incomplete in any case. So we are talking about a very large and extremely interesting research. I only wish I had the time to do it. I'm sorry, I have to dedicate now the rest of my years to build machines producing new clean energies and fuels, because that's the need of mankind. And these further coverings are left to future generations. Okay, so now let's go to the first step of the mechanics that, after so many trials and error, many mechanics that we tried and then rejected without never published them. There was no point in publishing them. Finally, we ended up with the classical mechanics that achieved all the five conditions. And indeed, the brackets were Lie admissible, so a covering of Lie, and admitted invariance, and then the first order variational principle, and the image, they admit a unique and unambiguous map to the Lie admissible Lie-Admissible operator formulation of hadronic mechanics. The starting point in everything that I do is Newton. Unless I can start from Newton, ladies and gentlemen, I have no interest. I am not even interested in looking at papers. As an editor, I'll review them and I will accept them if they are well written and plausible. But as a researcher, I have no interest whatsoever. Now, this includes also antimatter. I'm referring to one of the biggest scientific imbalances of the 20th century, in which matter was treated at all levels, from Newton all the way to second quantization, and antimatter only at the level of second quantization. As a result of this, ladies and gentlemen, remember lecture 1A, mankind is exposed to a potential, but still realistic risk of being hit by an antimatter asteroid without us even seeing it, because of this imbalance. The origin being that Einstein, all Einstein theories, both special and general relativity, they have no distinction between matter, neutral matter, and antimatter. And we will see this in separate lecture dedicated to antimatter. So let's see now the restriction. What we are doing here? First of all, we are only doing forward. We cannot do forward and backward. There's no time. Number one. Number two, we are talking about a single valued theory. Namely, the time has one value only, generalized, but is one value. It's coordinate one value. But this is a particular case of the branch of hadronic mechanics, which we call hyperstructure with a multi-valued hyperunit. So, and finally, it's only restricted to matter. Everything will change when we go to antimatter, beginning from Newton. So let's get started. Well, the first thing to do is to identify the Geno unit. As we will see shortly, the Geno unit is very easily identified, constructed from the non-self-adjoint forces, from the forces responsible for irreversibility. Exactly the same way as you cannot throw an Hamiltonian. No, you decide an Hamiltonian from the system. It's exactly the same thing for those non forces. So once you know the Geno unit, then you have to construct the Geno coordinate. Then you will realize that you need a Geno time, a Geno space, a Geno linear momentum, etc., each having its own Geno unit. After you do this, you construct the Geno fields, related Geno fields, and then you can construct the basic carrier space of the classical theory. We are here at the Newtonian level, which is this Geno space. Of course, it's a tensorial product of different Geno spaces. Of course, the total Geno unit is the direct product of all the various Geno units. Once you have set this mathematical foundation, the corresponding equations, which are called Newton-Santilli Geno equations, are uniquely and unambiguously set. There is not even an iota that you can change. What is let's examine those equations. The most visible aspect is the time ordering. Mathematically, by a product ordered by all products ordered to the right. But this includes physical quantities. No longer the mass. No, there's different masses are different depending on the process is forward or backward, as we will see on experimental grounds. The same for energy, etc. So there is an ordering of quantity, including the differential. Of course, is a Geno differential and so on. But another salient point is the absence of the very forces that we want to represent, which are the non-self-adjoint forces. You only see self-adjoint forces. Those are potential forces. Where are they gone? This is the main objective of the entire hadronic mechanics is not represented in the basic Newton equation. No, they're there. All the efforts is to represent them. And where are they? They are in the Geno differential, as some of you have listened to the lecture on Geno mathematics may remember. As a matter of fact, all the effort is to represent those forces with the Geno differential. Otherwise, we will never ever be able to formulate a first-order variational principle. Since the Geno differential was discovered only in 1996, we are talking about 1970s, from 1976 to 1996. We are talking about 30 years of total failures. Everything that we did to achieve the desired objective failed. And that's why after publishing a monograph on Birkhoffin mechanics, I decided not to publish any additional monograph or article in the field until I had achieved the objective. Okay, but this at least explains you the reason for so many trials and error. Well, okay, once you read this thing, you recognize that this is enormously broad. The degrees of freedom of these equations are beyond our comprehensions at this time. So there is no need to keep this variety for practical application. We assume here on Earth, I will elaborate in a moment on this point, we assume the simpler case that the time and coordinates are not lifted in our language. So therefore, the only Geno unit is that for the velocity. Once you do that, this equation, you write them down explicitly. You factorize the Geno unit in front, and you see this is a Newton, this is the conventional Lagrangian Hamiltonian term, and you see the appearance of an extra term. And this term is the term that provides directly universal representation of all the external forces in Lagrange and Hamilton's equation. The solution then is extremely elementary. This is simply integral to be solved. Since you identify the external forces with this expression here, and from there you compute the Geno unit is elementary, absolutely elementary. What is more important is to see the structure of this term. This term is 1 divided by the Geno unit multiplied by the derivative of the Geno unit with respect to time. Now, ladies and gentlemen, this has a fundamental character for the entire mechanics and illustrates again and again the fundamental character of Newton for all we know. Indeed, this emerges at the Newtonian level, and because it emerges at the Newtonian level, it becomes mandatory at all subsequent levels. What does this mean? This means that the solution, the only possible solutions for the Geno unit is that the Geno unit has to be an exponential. The Geno unit has to be an exponential. It's a fundamental physical feature of the entire representation of irreversibility at all levels. And here is, for instance, a very trivial, simple example with this velocity-dependent. This is really a high school type of level. This velocity-dependent represents the Geno unit in an extremely simple way. It is an exponential. Now, this will have, in a moment, will have very, very deep implications for recovering, to recover uniquely and unambiguously, to recover quantum mechanics, and all sorts of other implications. But let me now close this transparency with some comments on this equation. Ladies and gentlemen, allow me to indicate that the structural difference of those equations with Newton's equations are substantial. We're talking about a number of centuries of difference in thinking, in mathematical knowledge that was not available at the time of Newton and so on. But what are the structural differences? Well, first of all, is a conceptual difference. Then is a topological difference, and then there is a physical difference. The first and most important difference is that Newton conceived correctly for his time, conceived particles are being points. Galileo clearly adopts this point, saying Galileo was, when he did this experiment from the Pisa Tower, he said the dimension is irrelevant, it's the weight that is important. So what he was calling massive point. Exactly the same thing was adopted by Einstein. Ladies and gentlemen, this is the end of the chain, because to understand this equation now you cannot talk about points anymore. If you talk about points, you talk about local differential topology, you're talking about 20th century science. We are now on the 21st century, the beginning of the third millennium. This is too simplistic for the problem that we want to address now. It was not simplistic during Galileo-Einstein time, let me clarify. They made discoveries, substantial discoveries, but now science has to go ahead. So what we have to think about, that this equation represents a set of extended particles. Since they are extended, they are deformable. Since they are deformable, are generally non-spherical. And then they are under the most general possible forces. This means that those particles are extended objects under mutual penetration, thus for admitting forces that are conceptually beyond any dream of treating with, for instance, with the local Euclidean geometry of Newtonian mechanics. We are talking about centuries behind. Indeed, you can see here one simple representation of the Gano unit. You see the three axes, n1 square, n2 square, and 3 square, to represent the size of the particle. In this case, be careful, there are n of them in overlap, and those n quantities depend on many different local quantities, so they are variable, so the shape is variable, and so on. And the term actually representing the force is this exponentiation. Finally, I want to indicate that this is so broad that the basic topology underlying those equations has yet to be built. Indeed, the topology that we have now is called isotopology, which is the correct topology for the Lie isotopic formulations. We have there too already extended forces and so on, extended particles and so on, but we do not have irreversibility. So here we need a topology that not only incorporates the extended character of the isotopology, is non-local integral character and all this beauty, but in addition represents in an invariant way the irreversibility. Namely, because we are talking about processes among those extended particles that have only one direction in time, which is causal. That's why the direction is set everywhere, at every level. I hope I don't have the time to study this isotopology. I would love to, but I work on the isotopology. I cannot do this now. So I hope that mathematicians will understand the implications of this new topology yet to be built, because I believe will be beyond the imagination, can be the topology of the future studies of DNA, of genes, and let alone the topology for the interior of stars and so on.